So, good morning everyone. We are presenting our project on bamboo model, a bamboo table model under a rapid prototyping module. Our goal was to design a sustainable and eco-friendly table using bamboo. We have used bamboo because it has a high strain to weight ratio, and it is easily available in surroundings and eco-friendly to use. We created an 3D model using Tinkercad software of that bamboo model. Our goal was to design a lightweight, strong, economical table suitable for residential and commercial use. The main key features of the table was that bamboo strip tabletop, vertical cylindrical legs with no rings for support. Next, our main aim was to design a bamboo table using Tinkercad that is strong, stable, aesthetically pleasing, and environmental friendly. And then Going to the background of it, a table is one of the most essential furniture items and in homes and mostly used everywhere we can see. Traditional tables use wood, steel, or plastic. Bamboo has emerged as a sustainable alternative for those usages.
So during the planning phase, we focus on creating a design that is both strong and practical, not just visually good. We use Tinkercad to build the full 3D model because it is simple and allow precise dimension control. A table is made up of a few key components. The tabletop, which consists of 18 bamboo strips arranged side by side, four cylindrical legs, which act as the main support, apron rails, which connects the legs and hold the tabletop, and cross braces, which improve stability and prevent wobbling. We carefully select the dimensions. Tabletop size is 600 by 600 mm. Height is 750 mm, which is comfortable for normal use. One important thing we focus on was balance. If the structure is not balanced, even strong material like bamboo can fail. Before finalizing the design, we did a basic analysis to check whether the table will actually work in real conditions. First, we look at the load capacity of bamboo. Even though bamboo is lightweight, it is surprisingly strong. But still, we had to make sure it can handle daily usage. Then we checked how the load spreads across the tabletop. Since the top is made of multiple strips, it was important that weight doesn't concentrate in just one area. We also consider stability, especially in cases where weight is uneven, like when someone put a weight on the corner. Another important factor was bending of rails. If the apron rails are weak, the whole structure can become unstable. We also made sure the height follows standard ergonomic measurements so the table is comfortable to use.
After completing the design and analysis phase, we moved to the prototype development stage where we converted our conceptual idea into a detailed 3D model. For this purpose, we used Tinkercad, which is a CAD based modeling platform that allows precise design and assembly of components in a virtual environment. The development process was carried out in a systematic and step by step manner to ensure accuracy and structural consistency. Initially, we defined the overall dimensions of table, including the length, width, and height based on standard requirements. This step was important to maintain the proper proportions and usability. Next, we developed the tabletop structure. Instead of using a solid surface, we designed it with multiple bamboo strips, which were individually created and arranged in parallel. Special attention was given to their alignment and spacing to ensure uniformity and realistic representation. Following this, we designed the supporting legs of the table. The legs were modeled as a cylindrical structures and positioned at the four corners to provide balance to load support and stability. We then added rails which connected the legs horizontally. These components plays a crucial role in enhancing the structural integrity of the table by preventing lateral movements. To further strengthen to further strength the design, we incorporated cross braces and a central support element. These additions help in improving rigidity and reducing the chances of deformation under load. After designing all individual components, we performed a complete assembly of models. During this stage, we ensured proper alignment and accurate positioning and strong connectivity between all parts. Finally, we reviewed the model by generating different views such as top, front view, and side view, which helped us verifying the design and identify all possible errors. Overall, the prototype development process allowed us to transform our theoretical design into a practical and visually accurate model, while also giving us hand on experience with CAD tools and product development techniques.
So now I will be explaining the working principle of our model. So the concept is actually quite simple. When a load is placed on the tabletop, that's where everything starts. The bamboo strips on surface helps in distributing this load evenly, so no single point carries too much stress. From there, the load is transferred to the apron rails, which acts like connectors between the top and the legs. These rails then pass the load down to the legs of the table. Finally, the legs safely carry the load to the ground, completing the load transfer path. Now, coming to the stability, our structure is designed to remain stable using a few important elements. We have cross braces that prevents slide movement, node rings that strengthen the joints, and a center stretcher that adds extra support in the middle. All these components work together to make sure that the table remains stable and strong, even under the load.
So after testing, we observed that our prototype has good stability, uniform load distribution, and lightweight structure. So and advantages of it is like it is eco-friendly, it is lightweight, cost-effective, it is strong and aesthetic, it is naturally built, it's renewable source as well. And coming to the point of limitations, like what we experience is that it is sensitive to moisture, like it requires chemical treatment against insects and fungi. It is not that much durable, and it do have lower strength as compared to steel or hardwood, and connecting the joints requires too much craftsmanship.
So the cost analysis are, as you can see, the cost distribution about 7% of it is utility, 24% is labor, and 62% is material. This is the major cost distribution. The detailed cost breakdown is that the poles costing is almost 4 legs for 600. Bamboo strips are 720. Arrow nails pieces. As we sum up this, the total costing will be around 4,520 rupees. Uh, the major costs include bamboo materials, labor charges, utilities. This show that our product is economical and feasible for real world use. The cost distribution is eco-friendly and pocket friendly. Uh, the results. The key results are the structural stability is good, load distribution is uniform, design accuracy is verified, aesthetic quality is good, cost efficiency is economical, environment impact is very low. The bamboo table was successfully designed using Tinkercad. The structure is stable, economical, and eco-friendly. Our future improvements will be add lower shelf between cross braces for storage, add a foldable leg design for easy transport so that the table can be transported easily without any structural damage. Then protect varnish slash fire retardant coating. Add a fire retardant coating to the table. FEM simulation for quantitative stress analysis. From this we can see that our bamboo table is stable and eco-friendly and cost effective. Thank you.